All right, so some folks are having a bit of a hard time with this whole mole ratio thing. So here's an equation. It's for the combustion of propane. So propane plus oxygen yields, and like all hydrocarbon combustions, the products are CO2 and H2O. So I need to balance this, which we've learned. And so 3 carbons, so I'll need 3 carbon dioxides, 8 hydrogens. So that means if I have 4 sets of water, that will give me 8 hydrogens. And then that's going to give me, 6 oxygens, 4 oxygens, 10 oxygens. So 5 sets of O2 will balance that. So what that means is, for 1 mole of propane, I need 5 moles of oxygen. It will produce 3 moles of carbon dioxide and 4 moles of hydrogen. But very rarely are you going to react exactly 1 mole of propane. You're going to react some random amount of propane, probably with excess oxygen, and then you're going to produce carbon dioxide and water in the appropriate ratio to the amount of propane that you combusted. So what you're going to do is, and like any conversion, and mole ratios follow the same underlying or basic principle, is that it's always going to be the substance that you want to convert to, the substance that you're trying to answer a question about. So I'll just pithily call that want, and then that is going to be over the thing that you know information about, that you are given information about in the question, or we can just say the thing that you have. So let's say I combust, so I'm just making this up on the fly. Let's say it's 0.02. So I'm going to combust 0.02 moles of propane in the presence of just a ton of oxygen. So we know the oxygen is in excess. How much carbon dioxide and how much water will come about because of this reaction? Well, I'm going to take my 0.02 moles of propane, and that's the thing that I have. So when I multiply it by the mole ratio, C3H8 is going to go on the bottom. And let's do carbon dioxide first. So CO2 goes on top because that's the thing that I want to answer the question about. And then in terms of the numbers, I'm just going to go back to the balanced equation. And so it is 1 mole of propane for every 3 moles of CO2. And so when I combust 0.02 moles of propane, I will produce 0.06 moles of CO2. Same story with the waters, except this time the mole ratio is going to be different. So rather than, will this erase well enough that I don't have to? Ooh, all right. For once it's cooperating. So it's going to be now the thing that I want is not carbon dioxide, it is water. So it's going to be water on the top of the ratio, and what number should go there? This number. So it's going to be 4 moles of water for every 1 mole of propane, and 4 over 1 times 0.02. So when I combust 0.02 moles of propane in the presence of excess oxygen, I'm going to make 0.08 moles of water vapor. All right, so let's kind of flip this whole thing on its head. So let's say, rather than the way it would probably work most of the time in real life, let's say I am going to try and burn some propane in an environment that doesn't have unlimited oxygen. So the oxygen is limited. So let's say I'm an idiot and I decide I'm going to do some barbecuing in my living room, right? It's kind of cold outside. I don't want to be outside and cold, so I'm going to bring the grill inside. What bad thing could possibly happen now? And let's say in my living room, so how big is the living room? How many cubic meters would that be? So let's say I have, let's go 125. So I've got in my living room 125 moles of oxygen. And then tank is full of propane, so now the propane is going to be in excess. How much carbon dioxide and water vapor will I get here? So now, what I know, what I have, is 125 moles of oxygen. So 125 moles of O2 times, and so what I have is oxygen, so it's going to go down on the bottom. And first we'll try and figure out our carbon dioxide, and so CO2 is going to go on top. And the numbers that I'm going to put in there for the numerical ratio, it is 3 carbon dioxide, so 3 moles of carbon dioxide for every 5 moles of oxygen. And so when I exhaust the available oxygen in the room, so 125 times 3 over 5, that's going to be, what, 25, 75, and then to keep it right for sig figs, so 125 is 3 sig figs, so I'm going to have to go 75.0 moles of CO2. All right. And then if we wanted to figure out for water, we could totally do that. Can I tilt the camera a little bit down so I don't have to go erasing stuff? Sure, that works. So we'll go same 125 moles of O2. And then it's going to be times, now what do I have? It's still O2. So O2 goes on the bottom. Now though I'm looking for water. So, oh, you can't see that, so it's water, H2O. And then what numbers do I need to put, top and bottom? Well, back in the balanced equation when we could see it, it was 4 moles of water for every 5 moles of oxygen. And so 125 times 4/5, that's going to give us 100 with a decimal point, because it needs to be 3 sig figs. So 100 decimal point moles of water. So that is a little bit of mole ratios and some conversions. So hopefully that helps.